All right, for those of you who came in late, there's a URL up there that. So for those of you, Matplotlib, either the original or version 2. For those of you unfamiliar with the term OO, it stands for object-oriented. And so what we're going to cover here is attempting to do Matplotlib plotting, creating figures without using the traditional PyPlot interface. It helps to understand what's going on under the hood. You will really see how much the PyPlot interface just handles for you, and then we'll also cover doing some things like, instead of using plotting methods, trying to create artists by hand, and seeing what goes on under the hood when you call these simple plot methods. So we have here to start is just the usual, bare basic kind of beginning of a script in Matplotlib. You have your imported NumPy and Matplotlib's PyPlot, and we'll make some random data. And then here we make a scatter plot, set the limits, give it a title, and call show, which you really don't need in the notebook. And you get a nice pretty graph, has a title, you see random data. Shift enter. So Shift enter will run the current cell and move to the next one. Control enter will run the current cell without moving.
You want it to appear in line.
Yes. Think.
Yeah.
Kernel busy.
I'm getting a kernel, like it's just not running it. All right.
If it didn't work right, to appear.
It's putting it off the screen, off the notebook, so you have to
Just to be clear, oh yeah, mine's printed out off the screen as well.
For users who didn't start with -pilot, you need to do %pilot. Yeah.
Okay, so what Min just said was, if you didn't start with -pylab, which I didn't think I had, but I must have, if you just do %pylab space inline, at any box, just make a new one, or does it matter?
Yeah, you can do it again.
Okay, so I could go right here and go %pylab inline, and there you go. I had a lot of issues going back and forth between them with the GUI toolkit, so I just tried to avoid it as much as possible. So that's usual Matplotlib for any of us, all of us familiar with it. That looks normal. So when using the PyPlot or PyLab interface, it handles a lot of magic under the hood that goes on in terms of creating a figure. Matplotlib supports a wide variety of graphical toolkit backends, as well as the AG image backend. So we have no GUI toolkit with AG, and then also Qt4, WX Windows, GTK, Cocoa on Mac OS, FLTK, and TK. So all of those different toolkits, so you have maximum odds of something working on any given platform. But as a consequence, there's a lot of magic in order to abstract that away, so you can just call figure and get the appropriate window. It also, PyLab provides more of a stateful interface. So it's tracking what is the current figure, what is the current axes, so that you need to make sure when you're using that interface, you keep track, okay, I'm done with this figure, now I can move on to the next one. And so if you don't hold on to the appropriate objects, it's very difficult to go back and modify them. So it's pretty much like global variables. And programming maybe 201 is global variables are bad. And so it makes a very MATLAB-like interface in terms of ease of creating figures, but from a code maintainability and in terms of using the full power of the interface, you're not getting quite everything out of it. So if we move to the next one, you see here, and this is where I'm going to get in trouble with the inline. So if I go here and get rid of show, yeah, so for those of you doing the inline and not getting windows up, get rid of the Qt4 and show. Just look like that, and it should, what just happened? There we go. Ha. Okay. So instead of show, we use display fig to tell the IPython notebook to display the figure. But that's specific to the notebook and not Matplotlib. What we see here is first we have to do the we pick a backend, and so we have this import line from Matplotlib backends. In this case, I chose ag since I'm using inline. Ag is the image only backend, and so will play nicely with the inline setting of the notebook. And so we import this new figure manager, which every backend has a function that is basically used to manage and create new figures. So we call it, and we call it new figure manager, say, okay, I want to create figure 1, and then I want to grab, you can use this .canvas.figure to actually grab the figure instance, which is the object you're used to getting when you call pyplot.figure. And obviously that's already a little bit ugly because you're picking one backend. Your script won't work. Well, it'll always work when create an image. You can't, but with this script you can't. Then you get a GUI window up. If you pick Qt4, it won't work on platforms where you don't have Qt4 installed, et cetera, et cetera. So while it works in terms of getting the right object, it's not very friendly. From there, after we get a figure object, we can use that figure object to create an axes object with this add subplot command. There are other ways to do it. That's pretty much the easiest and most straightforward, which basically just says we're going to create a grid of subplots with one row, one column. I want the first one. We inherited this one-based indexing from Matplotlib, or from MATLAB. And then instead of just calling pyplot.scatter and xlim and whatnot, we call these as methods on the axes object. And so you can see if we had more than one figure here, if we wanted a second axes, if we wanted to instead say, let's do 2 rows, and we can do a second one here. Good enough. So now, with that second plot, then there's different limits, but the important part is it's very easy to see which axes you're working on. There's no calls to get current axis. There's no worrying about what is the current axis. It's all very explicit in your code what object is being used for plotting.
I'm getting an input error on display. On name error, I'm sorry.
Display should come from IPython, or from the notebook. Basically, it's a way to tell the notebook to display the figure in line. For most, when you're used to working with normal scripts, that's the equivalent of show. But for the notebook here, I had to change it a little bit. So, like I said, the benefits, it's more object-oriented. You track specific objects just like you would in normal code. I mean, one of the things about when using the pyplot interface, if you're not tracking it, it seems very antithetical to the normal way you program, where you create an object, you create new objects from that, et cetera. So there is a way to do that in Matplotlib. It's just not as well advertised or demonstrated. However, like I said, the trade-offs are you're doing it specific to a given backend. And so often the best approach is a mix. So what I tend to do, and
can I quickly?
Absolutely.
You have the ax.set title. Is a figure, does it have like a collection of axes? Is that what?
That's a good question. Okay, so let me step back for a second and go over the hierarchy here. So what you have is you have a figure which represents one plot window. So if you're working interactively and you bring up a GUI toolkit window, that is a single figure. Each figure has one or more axes objects in there that are actually in control of handling your plot boundaries, the ticking, the actual plot methods are on there, managing the different artists that are being drawn. All of those things are on an axis, and so you can have multiple axes within a single figure. but you only one figure corresponds to one GUI window or one image.
Does the figure know about the axes that are within?
Yes. Yes, the figure tracks. And there's actually a lot of, the axis knows what figure it belongs to, and the figure knows what axes it has, etc.
And so now I'm doing set title, and so I noticed I put a set title on the other one, each has its own. Is there a figure title on top of these, or what?
There is. The question was about whether or not there's a figure title as well as the axes titles, and there is a, we call a soup title, yeah. I don't know if it stands for soup or what, but it's fig dot, or is it? It's I know there's PLT for in pyplot.soup title, which will create a title about where it thinks it should go up at the top of the plot. I guess you can give it a location, and so that's a way to basically make a text object that lives outside the axes objects. So often, the best way to address, using the object-oriented type of interface while also not making code that only runs in specific instances is to kind of do a hybrid approach. And so here, we call you go to the PLT as pyplot. So, just don't have it here explicitly. So we use figure off of pyplot because that handles figuring out what backend should be set, looking at your RC parameters or what was passed in the command line, and sets up all the function objects so everything points correctly. And so all you have to do is use pyplot.figure, and that just works. And anywhere you want to run it that has a proper Matplotlib installed, the script will just work. But from there, we can use the figure object then to make a new axis, just like we did before, and call scatter and all the other appropriate plotting functions directly on the axes. And so you still get the benefit of explicitly managing your objects and tracking what's going on, but you don't have to necessarily figure out what backends are installed, what's available, what makes sense. And then basically you have it bookended by two calls. The figure, one or more figures, and at the very end, a show. And so, same plot, just what I think is probably the best approach as far as code goes.
So if I'm doing, just trying to programmatically generate my figures, instead of show, could I just do like, say fig or something?
I believe it's fig dot. So the question was as far as programmatically generating figures instead of show. And so the answer to that is there's a fig.savefig. I think there's also a print figure, and that's the easiest way. You just give it a file name, you give it DPI, and a few other options. And in my experience, that's one of the things Matplotlib does off the bat better than MATLAB. It's just easily programmatically generating figures.
And it should always be done before you call show.
Correct. Yes, that's a good point, is that show should be basically the last thing you do in any script. Last time I checked, I know there's been some discussions, but last time I checked, show can only be called once. And so you should do everything before that, call savefig before then call show. Yeah. There has been some work to try and make it function better when calling show more than once, but certainly in older versions, that's a surefire way to end up with a backtrace.
So what's show actually doing?
Show basically starts the GUI toolkit's event loop. And so if you've ever done any graphical user interface work, you have this loop that just keeps spinning, and it gets events and it handles them. And so what you have here in Matplotlib is you set up a whole bunch of data and objects, and then you call show, and that starts the GUI, so events can be handled. Your mouse clicks, your keyboard events, anything else that's running. All right, so we'll hit here for a small exercise. It's not particularly in depth, but we'll go through and go ahead and work to not use the pyplot interface. So there should be no importing matplotlib.pyplot. It should be a lookup in the previous code to try and see about where to go. But what we want to do is make a new figure using new figure manager. Pick your backend of your choice. If you're doing inline, you're probably going to do backend_ag. Use that figure to make an axes object, and then use the axes. They have methods for all plotting commands. In this case, I said step, really, take your pick. I just figured something different other than just the standard line plot. So you already have the data there. and I'll wander around if anyone has questions. If I've been unintentionally vague here, please let me know.
Yeah, okay, so if you change that, you're up max, so change the QC4 Act to Mac OS. Try X. Okay, that's different.
Oh, you mean, yes, yeah, I was doing that. Yeah, that's not working.
Turn it on. Okay, so instead of Mac OS,
But that breaks.
that new Mac,
Then it breaks when you try to do plots. Show doesn't work.
Restart. I've run it so many times over the last week. Did it restart? You just gotta restart. Just rerun the block. Right into the block. 2 or 3 different installs. Oh, okay. Well, I remember I've been doing this now. So for in the notebook, just display parentheses. Sorry. Display in the yeah. So because we're running an active notebook, to tell them to force it to display the figure in line.
Right.
Aha.
Yeah, and this should be the only PD that's actually working. What our plan was for all this sort of,
Right.
I don't understand what's going on. What's a canvas?
Okay. The canvas is the actual GUI widget that's being
So there's inside of the widget.
window. Inside the window, there's a canvas that actually tracks all.
Yeah. And inside the canvas is the figure.
Now the figure contains a canvas. It's just the easiest way to go and get to the reference figures.
Oh, the figure contains the canvas.
Yeah. It's just going up. It's just basically going higher.
Yeah. But is it a one-to-one thing?
Yes. Each canvas is one figure. Each one has one canvas. So definitely an implementation. Well, not implementation. Is it with low level detail?
Yeah.
This is why that's so bad. How would you use your file for you? Setting. Like cells. So that would be QT back in, and then with Mac, instead of QT for Mac, we Mac OS X. So we have a Mac backend. So Mac OS X.
backend?
I actually do have a Matplotlib one in here.
Yeah, because we need to input this show.
Oh, yeah, you already reload everything.
Yeah, good Firefox too.
I was like,
Oh, we need the history. Yeah, I actually have never worked with Firefox, so this is
Basically showing it the way, that's how you go, if you're, no pipelines. Like, error.
almost before I've ever used Python, I just use
One and the same, basically, pilot, plus a bunch of non-Python. Okay. This is no Python. Yeah, so this is basically no simple stuff. This is the way it's
yeah, but I tried, it's,
yeah, so I mean, there's some back-end incompatibility, we're picking the wrong one there, I don't know which one's running, but that gets you the least headache.
it's here, right?
of most
Yeah.
quality.
Well, it's, he mentioned it was this one, but I don't know.
Okay, now we're seeing
Looks like I cannot.
If you're having problems getting the figure to actually pop up, probably not the worst thing in the world, just instead of being the pure, absolute, no piplot whatsoever, cheat just a little bit and use the PLT equal, or fig equals piplot.figure, and then you don't need a show. But that's part of the point of the exercise, was just to show how problematic it is to get it right if you're actually going to try and use no piplot whatsoever. But everything else can be done just fine using the correct method calls and holding on to the objects. How many people do you have still trying to do this? Okay.
It's basically a package that helps QT, it's a binding package that helps PyQt know what version of and you can then deal changes in the database so specify that way they can talk about query QT saying, okay, what is it that you do not have, what is it that you have, or not have. Yeah, it is. Not to give you
that's when I started trying to find that certificate. And then
So that creates an option here, and just the same way he's doing that he wants us to do here, showing why that's going to be your objects instead of
Yeah, you have to, we have to quit, yeah, that's what I meant to.
Yeah.
I was trying to, but yeah.
So that works. It's sort of. I tried again.
Yes.
Somewhere, some of the graphic. Make it seem as if it's so the thing.
I mean, I'm not installing it.
Right, it's not so big,
I sometimes
So let's see, and I couldn't find this. So
Python is not installed as a framework. Matplotlib is back in the network. Python is not installed as a
Home directory.
So what does it mean?
Well, that's why I can't find out how. Because trying to make them and
That's what you need to, once you've got the figure in your business.
or let's see if they can just first training. Yeah. Yeah, it's so like it's
Well, you haven't done anything with the physics yet. You got it.
Yeah, you got it.
So without these three lines, you got your axis equals.
something? But before I was not using figure.
Oh, yeah, let's,
The scatter.
Oh, with the open parentheses. I couldn't find it there.
There should be access, AXF. Oh, is it not documented?
Sure.
So you should just go axes step.
I don't think it is documented. That one. Yeah, that's all the steps.
Of course.
Yeah.
Okay.
So that's why.
I picked one that's from the course.
Should I raise an issue somewhere?
Sure.
All right, well, I think at this point it's probably good to start moving on to another, keep going here. For the record, here's my solution. Could have been, not the only way to do it. But we just, did like before, create the figure from the figure manager. In this case, I'm using the ag backend. Add a subplot, and if you didn't catch it, I apologize if you actually went to a lot more coding effort to do it, but there's a step method of axes to make those step plots. So in theory, you could have done it quickly. Of course, I lost my data, so I'm going to get a trace back. There we go. And display it. So for those of you who didn't know that and worked at it, well, now you know there's a step method. Sorry. All right, so now we can do even more objects. We're not limited to just figures, axes, and plot methods here. Basically, every plot method is just being very nice and doing a lot of work for you in terms of creating one or more artists. An artist is something that draws something. Kind of makes sense. So for every plot method, it's going to create one or more of these artists to represent what kind of plot you've asked it to make. For a line plot, this is just a line object. For things like contours, then it becomes a bit more complex in terms of the object. And some plots, like error bar plots, will actually make more than one object. It also handles setting up transforms so that your data adjusts to when the data, or your plot objects adjust to when the data limits are and things like that. Handles processing missing data for you, NANDs, and using masked arrays. Some plot methods can just use that directly. Some need a lot more of removing bad points. And of course, you need to update certain axes attributes so it can track it or update plotting limits automatically, things like that. So we can go through that effort. For simple plots, it's actually not that painful. So for instance here, we can directly import the line 2D object. That's the object that all basic calls to plot end up creating. So we make a figure just like before, add an axis to it, axes object to it, and create the line object. And so the only thing you need to do after you create the line object is tell the axes to add it to its list of artists. And then we'll call show. And of course it's going to error. Ah. Thank you. I need to get the data back from the beginning of the script. It was my bad for reusing names in the example or in the exercise. There we go. A very noisy spiderweb plot there. So this looks good, but there's no data limits updates.
So line 2D will create all the segments between all the plots.
Correct. It'll just process two arrays of X, Y, and just connect them in pairs. So there's a command on the axes that say auto scale the view. Look at your artist and see what your data limit should be and do some smart things with it. And for fun, just an example here, we can also change the line color using a method. You aren't locked into any attributes that are set initially. They're still just objects. You can still change properties. And then we'll force a redraw with the plt.draw. So if we do that, There we go. So you need a display fig. I think when I was doing this originally, I had it popped out because these are some of the challenges I was having with the inline mode. But if you just put the display fig in there, it pops up beautifully down there. Notice the axes limits are still not scaled properly. So if view's still off, it's not what I expected, but what happened was, if you notice up here, when I added the line, I did add artist, and that works just fine. That put it in the list of things to draw, and it showed up. But to be efficient, Matplotlib only considers a couple specific types of plot elements to update its or patches, not collections. Collections is one of the ones it avoids because it has so many things to check. Doing bounds could end up taking a long time. So patches and lines are easy enough to check, so it processes those to update the bounds automatically. So what we need to do is instead there's an add line method. If we use that, okay, just looks like before, just a different method, but this time make the line green and dash just because I can. And we'll update that, and bingo. Now your plot limits are updated properly.
Why wouldn't the plot limits off to begin with?
Because it never updated them because we added the artist by hand. That's one of the things that Matplotlib handles for you when you do the plot methods is telling the axes you need to check your bounds and see if everyone's within your limits, and if not, update them. So when dealing with, if you're creating, yes?
I'm looking at the thing, I realize now it's rectangular because the limits are not the same. But can you specify, when you're getting something drawn, that the pixel count per unit on each of the axes is the same?
Absolutely. So the question was about, can you control make sure the pixel count in each dimension is the same? And so the axes object has a set aspect method. And so you can say, I want an aspect ratio of 1.0, which means equal mappings or equal sizes in each dimension, number of pixels. And so you can also tell it what to adjust. And so I wanted to adjust my data limits so that we achieve that uniform scaling. And of course it didn't do what I expected it to do. Oh, okay. It changed the data limits to not be, okay. Yeah, so it's not a square plot, but the data limits are equal. Thank you.
I was going to ask quick, I called axis type here, and it didn't adjust the data limits correctly. Is that because the type only works for certain patches?
To be honest right now, I'd be guessing. The question was about calling axes tight, and I don't actually know offhand. But I would think that would work, so I'd be curious to look at the code and see if it's a bug or if that's by design. So now we have properly scaled axes, added it by hand, no calls to any plot methods. We just made something an artist, something to draw, and we gave it some data. So for reference, there are a lot of methods on the axes object for adding these variety of artists. Any of the artists can work with add artist, but as we saw, you don't necessarily get it handled completely right. You don't necessarily get behavior of automatically updating your data limits properly. And sometimes, if it's more specific, it makes sense to use these other add line, add collection, add patch. And so for instance, we can go a little further, and another artist we have is a circle collection, which unsurprisingly is a collection of circles. So do the same dance again. We're going to see this a lot, is create figure, add axes. In this case, I'm making an empty array, and I'm going to fill it with the number 20. And that's because when you create circles, you have to give it an array of sizes. That has to be the same as your size of your X and Y data. So here we create a circle collection with everyone's going to be the same size at 20. That's in square pixels. So it represents the area of the circle. The area of the circle instead of giving it the radius, you're giving it the area in terms of pixels. It makes, makes it easier if you're doing it in terms of display. There are ways with transforms you can make that size come out, I think, in data units, but gets a little tricky. So that's why it makes it easier if you just hand it to it in display units. Then we give it the offsets, which is just a list of the centers of all the circles. Like I mentioned before, one of the things the axes handles for you is controlling the transforms. So here we give it the actual transform, which I don't want to go into that. That could be a tutorial into itself. But basically, a transform handles converting from one coordinate system to another. In this case, transdata handles converting from data units, things you give it a plot, to, in this case, the normalized axis coordinates, 0 to 1. And then we give it an edge color and a face color. Red and cyan should be nice and hideous, but this isn't about aesthetic plots. So if we run this, and behold, we get the same hideous circles, but everything showed up just like you expect. With again, no plotting methods. So we can expand this, and when this often becomes, oh, go ahead.
I thought you said that the X only size for lines and patches, but it only size for the collection.
It did. Did it make a liar out of me? I specifically remember looking at the code to try and figure out what made auto-scale view work in order to make this thing behave like I expected.
Circles are also easy, right?
I can't make that scroll down. Okay, well, I'm not going to be able to look right now, but you're right. It does seem to have auto-scaled it right, and I'm not, to be honest, sure right. So, or I'm not, to be honest, I am not sure why it worked. There we go. Okay, my wheel on my mouse has just stopped working. All right, so. The mouse is working. I just think the GUI went weird. I'll get it when we break for something. So, one of the ways this is often useful is if you want to add a square or some kind of region to a plot to highlight something of interest, to make the plot easier to understand to other people. And I don't think I've ever created a circle collection by hand before I did this tutorial, but I've often created individual circles and rectangles to put on a plot and make it easy to annotate the plots. Partially because I hate trying to Photoshop images afterwards. It's kind of ugly to do that, and it takes it out of, for me, my workflow of everything's automatically generated. Just run a script, I get all my plots for my papers, and I'm done. And so any step that makes it automated and reproducible is a win for me. And so here we can import from patches a circle and a rectangle. Very straightforward. We're going to center the circle at 0, 0 with a radius of 1. It's going to be black. Alpha controls the transparency, so that way we don't block out the data with this big black blob. And actually we'll make it a light blue, not black blob. It'll have black outline. Add that to as a patch to the axes, and then we'll make a rectangles. This will be the lower left corner. Will be at negative 1.5, 1.5. The width is 0.75 and the height is 0.75. Also make it a little translucent, and for fun we'll make it purple. Add that and draw it. And add that for inline. And it's going to make a liar of me. No, it's just a warning. Okay, now it just hates me. So for those of you who can probably see better at your computers than on the screen, there is the purple rectangle here. If I move it down, there is the translucent circle as well. And for some reason, I'll win one way or another. You can see it definitely has some use in terms of highlighting regions of interest. If this was some outlier data, can highlight that easily for publication, and also perhaps maybe some theoretical bounds on something. And so it's very easy to add these artists that, you know, highlight things you want without needing to figure out some kludge of reusing a plot method to get that.
My alpha worked for a bit, then I took over now.
Yeah, same here.
Really? That's, it's a feature.
How can I, now will they add up, right?
So if you ran it a bunch of times, because that particular line of code is reusing the previous figure, that's probably what's going on. So if you put it all in one block and re-execute that same block, making a new figure and axes, you would probably not get that effect. So actually it was working correctly. All right, so I can't see the exercise very well, but I have to fix this mouse when we break here. So the exercise is we're going to try and make a plot without any plotting methods. I'm not particularly partial to what plot you do if you have something you're curious to explore. We just want to try to do it using the artist directly, the line 2D object.
Is there a function for clearing the axes?
For clearing the axes, plt dot, yeah, CLA. Yes, if you pass, so the question is, can you change the z-axis so you can basically change the order that they're drawn so one artist is on top of the other. You want to pass the z order parameter when you create the artist, and that'll control how things stack up. So try not to use, you know, any of the plot methods. The simplest one's going to be line 2D. And I'll tell you that up front. You can use collections to reproduce scatter. So if you're looking for something, make a line plot and maybe put 2 ellipses on there. You can import ellipse from matplotlib.patches. There's also other artists of rectangle, circle, ellipse, arc, arrow, polygon, and that's just some of the list. There's a large list of them. And so, you know, if you have data, you have some curve you are dying to plot, go at it. Otherwise, here's a starting point. It should be more than just a plain sine wave. And while you guys do that, I'm going to fix my mouse. Rectangle. All right. We about ready to move on? I don't see anyone craving to do this longer, so here's what I came up with. I did an ellipse and a rectangle, probably because that's what I described up there. I said 2 ellipses, so I got crafty. Create the figure and then add the subplot as usual. Make the line by hand. We're going with dark green with circles to mark the points, which will be...
Sorry to interrupt. I keep wondering what that 111 is.
So that's basically, when you create an axis, you can give it an arbitrary range. You can since the axis is the plotting area, you can make an arbitrary plotting area on a figure. You can give it in normalized coordinates 0 to 1.
So those are the starter X, Y, Z.
Well, so it's hard to pick the right ones but have the right margins to leave space for labels and stuff. So the easiest way is to just use what we have. Matplotlib has machinery for making multi-panel figures. And so what this does is creates a multi-panel figure with 1 panel. And that syntax is basically borrowed from MATLAB, the MATLAB subplot command, where you say how many rows, how many columns, and then what number of the grid are you working with. In this case, MATLAB is based on Fortran, so it uses 1-based indexing. So it's a quick and dirty way. It's less typing, and it's easier than figuring out what the right margin is to leave around an axis object. Because there's also machinery within Matplotlib where you can interactively adjust those margins. And if you do the subplot, it'll adjust that for you. If you do it by hand, you're responsible for keeping track of everything. So
basically, the 111 gives you 1 plot in the upper right-hand corner and chooses that one.
Correct. So it's an easy way to ask for 1 plot.
GCA.
You can do GCA, but that would be against the principles of doing the object-oriented no PyPlot.
Quite.
So I just, this becomes, the first 2 lines of every script I write end up being figure axis with that.
I wasn't here, but did you show the subplots?
That's next section, so. All right, so we made the line by hand and added it to the axes and made an ellipse that is some pretend feature of interest. It's filled, it has an alpha, and here's the Z order to make sure it appears on top. We had a question about that earlier. And then also make a rectangle, same Z order. Added both of those as patches, here and here. Went ahead and added a grid and some labels, and then told it to make sure to rescale the data. And this one worked. So, in this case, you had the rectangle stretching across the whole plot, representing some kind of sweet spot or something. So, I'll finish off this section here. Why would you ever want to know this? And I think you can impress your friends with it, and something else, and then profit. Really, it's good. Some of these artists are good for simple annotations. There's also very complex annotation support in Matplotlib. We're not covering that today. But it's a very quick way to add a circle to a plot and highlight something. This is basically how you start making your own custom plots in Matplotlib. I mean, everything in there is based around artists. So if you learn how to use the artists, you can start making more and more complex plots that suit your particular domain's needs. And then it's also the way when you need to modify things. Every one of these every plot command is actually returning the artist it creates. So you can get access to these and modify them afterwards for things like animations, which we'll cover later. And it's always better to understand what's going on underneath so you can figure out what's going wrong when inevitably something goes wrong. So I was telling you that the plots do return objects, and of course that just blew up because I don't have the data. So we'll change that to DT and X, because all I want to show here is when you do get one, it returns this line 2D object, just like the same kind of object we were creating up here in the plots. Plot returns that to you. You have access to that. You can do things. You can, say line equals that. So it's not line color. We'll go set color. And same with scatter. We saw this making a circle collection earlier. We can say that, and again you see it says, in this case it's a path collection. For scatter, Matplotlib uses just a generic collection that can print pretty much any path. So we'll end using OO for now. Or not for now, we're done with this one. So we're going to leave this page. And now we will move on to, we'll do the axes. So now we're going to cover the laying out and control of axes question.
Yeah, sorry, it's a bit off topic.
It's all right.
I drew an arrow, and it's very skewed. Are there any nice arrows?
There should be nice arrows. The arrows have a lot of options in terms of controlling points and controlling how the head of the arrow looks. You can be very swept back, kind of points well back, or you can have the normal blocky kind of arrow. Getting those points right can be a bit of an art form. So my best advice would be to look at the gallery, which would have, I think, no end to the number of examples. Especially the annotation support was written by a very talented contributor, JJ, who has put up many very beautiful examples that show a lot of the features capable there. So we've experienced that subplot command, the 111. So we'll cover a bit more of what we can do in terms of laying out multi-panel figures, because one figure is never enough. You always want more than one. At least whenever I'm doing it, it's more than one. So we'll set up some data. Go ahead, I don't think I need that, but we'll leave it in. Some more random data. So one way to get layout of multiple axes is the MATLAB style subplot command. And so in this case, we're finally not using 1, 1, 1, but we're going to go over and we're going to make a 3-row by 3-column array, a grid of subplots. And we're going to loop from 0 to 9 and add each one of these subplots. We need to do the +1 because we have that horrendous Fortran notation. And then we'll just plot our random data scaled, or one column of the random data for y in each of those plots. And you see the random data, and you see a whole lot of mess of labels. I mean, they're overlapping. It would improve some if I could, I guess I can try and do that now. I guess it's a static image. On the GUI, you can make the figure bigger on your screen, and then sometimes they don't overlap, but really that's not a solution. We also have is sometimes you make these subplots, and maybe everybody has the same x-axis as we have in this case, and you want to share it so that when you pan one, you can pan them all. And so you can do that, but basically what it amounts to is we have to hold on to one of the axes. So we create, we have this started off as none, and we loop over 9 times, do the same kind of adding of the subplots here, and we pass these parameters share x and share y, which basically says everybody, we're going to get our limits from whatever axis object you pass. They can be 2 different ones if you want to get your share y limits from some figures and share x from another. If you have a certain arrangement of 3 plots, for instance, that might be useful. And we'll do the plot, but then, the first time through we have to set that axis object and hold on to it. And it works. It's not horrible code. It's not the prettiest either. That's really not going to show much since it's not interactive, since I'm working inline, but trust me, I would say if you panned one of these figures, pan the other. If you really want to see it, stop your notebook and don't run with -pylab unless, you know another way to, can you change that while running?
While running, I generally avoid using starting with -pylab so I can use the magic.
Okay, gotcha.
So it's not like you have to change you have to pan the first figure, right?
You can pan any of them, and in actuality, none is a master here. So they all are treated equally. They just, you move one, they all pan. In fact, this is bugging me, so I think I am going to restart my notebook. So, restarting notebook and then bring up axes again. No inline, so I should get GUI windows. Okay, thank you. Right. Except I didn't.
What's the backend for OS X?
There's Mac OS X is one of them. I think Pylab Auto. Will that work?
Just Pylab.
Okay, restart again. Okay, there we go. So mine's working at least here. So Pylab, just Pylab no inline should work. So you see here, if we pan around, only one moves there. Come down here. Now if we pan around, you see they all pan together. It's a very nice feature. but quite frankly, there's an easier way. Thanks to Fernando Perez, there's within PyPlot, which this one's not available any other place, so you have to use PyPlot for this command. There's the subplots command. And so what that does is it will create a figure and an axis all in one go. You just give it the same kind of grid. And then you can say, instead of just giving an axis to share, just say, I want you to share x-axis between these plots. I want you to share y-axis. And then you can just, here I iterate over all those axes objects that were returned and plot on them. So 3 lines. And I get the same plot with some differences. You'll notice it hid the x labels and y labels that are basically superfluous, since they're all, you told that you're plotting on the same axes. And that already helped clean up the plot immensely. And of course, the panning, and I should say not just panning, but zooming as well, all stay the same. So subplots is a simple function, but it's amazing how much it cleans things up and makes it easier. And it actually returns a NumPy array of axes objects. So you can slice it, you can work with it. It's a collection, so you can do things on only certain axes if you so choose. Whatever makes sense.
That's a 3x3, is that?
In this case, it's a 3x3 array of axes objects. Obviously, it depends on what your grid is. I think if you only have one, it squeezes it by default. So if you do a 3x1, it won't be a 2-dimensional object.
If you do a 1x1.
Yeah, if you do, and if this could replace a lot of that code. I didn't really think about that when I was writing the other tutorial, so you probably could replace a lot of those fig equals plot that figure, ax equals plot, fig add subplot with just fig ax equals subplots. So we got rid of the overlapping labels by removing redundant ones. But sometimes your labels are not redundant. Sometimes you have this, and of course it already spread it out. So what you can do, here, let me do this again because I hit my punchline. So we have this. You see, we're back to, as John Hunter calls it, label soup. Just labels everywhere, overlapping. Again, this is what I meant earlier. You can make it bigger and it helps, but it's not a great solution. So what we have is this function called tight layout. And basically, it's intelligent enough to look at all the axes and the labels and try to shrink them so you can have enough space. And so here we have the same subplots. We're not sharing here. It makes a bunch of plots, which isn't really all that important. Just have some work there just to make sure we have everybody with different scales and big labels. But with tight layout, you see all the plots are smaller. There's plenty of space, even when I don't make it big. Everything's spread out. You can read everything. At least no axes are overlapping themselves. You see along the bottom here, you still get some overlap.
There is similar quick and easy for that kind of...
Getting there. Another one?
I'm getting a trace back on that tight layout.
What version of that?
I think that's
1.1 should be enough. I actually made an effort to make sure I wasn't on the development version for this. I'll come back to that. So, it's a library design philosophy, for one, of not doing too much magic, because very often it's very difficult to undo magic. So it's kind of an opt-in type of thing where if you want that, if you're having problems, opt in for it. And we'll get to some other methods that make this also superfluous for certain plots. So it's when you need it, it's there. And it's actually a very recent addition. So before you really had to play with other parameters to try and clean it up. So it's new, and we just by default don't like too much magic, except when we're trying to emulate MATLAB. It's kind of mixed like that.
Is tight layout helping from using subplots?
I do not know off the top of my head. The question was, is tight layout decoupled from using subplots? My gut says no.
No, and we had to do a lot of special code to make it work actually grid.
Okay, so
Actually grid tried to emulate what needed to be done, but it's still not quite the same. It is not decoupled from the subplots at all.
okay, so again, if you're doing axes by hand, if you're adding an axis at a given set of normalized coordinates, you're out of luck. So
If you're doing them by hand, it is still technically possible. You just got to make sure that the axes that you're producing are wrapped by the sub-axes.
you can do a lot of work by hand to try and make hand-controlled axes look like subplots if you really want to go through all the effort that's going underneath the covers.
The reason why we put that magic.
My advice would be use subplots and don't make your life unduly complex. And if you need more complex layouts, there are a lot of tools I'll cover here that obviate the need for going through a lot of pain. So one of the things that we just had a question about trying to control the tick labels overlapping. So, on top of the tight layout, what we can do is there's a very easy way on the axes object to control where those tick marks end up. And so we have a function. Let me step back for a second. So axes ticking is controlled by what's called a locator. You have locators that control where ticks end up, and you have formatters that control how is the text assigned to those ticks. And there's a lot of power underneath. If you're interested in that, I suggest taking a look at the docs, but you really can have a lot of control over ticks, how they're written and whatnot. We'll cover a little bit here. So there's a function here that adjusts the parameters that are passed to the locator. In this case, I say, ax locator params, and I say I want both the x and y axis to be adjusted. And so we have the default locator basically tries to pick at most x points to tick. It tries to do it intelligently based on the range, tries to pick pretty numbers, multiples of 1, 2, 5, 10, those kinds of multiples. So here, before it defaults to 7 or 10 or something, so we just reduce it to 4. And you see already, actually it controls the number of spacings, not the ticks themselves, I think. Yeah, so 1, 2, 3, 4 spacings. And so already that cleaned up a lot of it. You see still some problems here when things are really long. And so what we can also do is we can control how those ticks are printed. And so you can also, by default, very easily change the label format. And so the default formatter actually tries to be intelligent. It will optionally use scientific notation when it thinks it should. If you get really small or big numbers, it automatically kicks over about on the order of 10 million. So what we do here is we just say at 0.1 or 10, I want you to start using scientific notation. And so you end up with those scientific notation tick marks. So then all the overlapping problems taken care of, and plot looks a lot more aesthetically pleasing, a lot closer to something you could come close to publishing, and for not many lines of code. So, and these were things I just recently learned about. So subplots, locator params, and tick label params are very powerful in terms of cleaning up a plot very easily. So for our last one, I think it's supposed to break at 3, I hope. So we will go ahead and attempt to do an exercise using this. I've got some data here for you. I suggested doing 2x4 columns. And each row plot should be, the top row should be x, using x0 for the x data. Bottom row should be x1. And then the columns need to use the appropriate data for y matching. So for instance, row 2, column 3, y1, y2. At least that's the easy way to do your loops. If you don't follow it, don't worry about it. Just the important part is to play with the data and play with the ticking and the subplots. So if you have something you want to do, by all means. It's done, feels like getting up. I mean, we're breaking at 3 for coffee and whatnot. We start again at 3:15. So I left you with some confusing data and trying to make multi-panel plots with it. And so I apologize that the data was a little obtuse. I'll learn. So here was my solution to that problem. Basically call subplots. We wanted 2 rows and 4 columns. And I just went ahead and shared the x-axis across all of them. I mean, some of them were slightly different, but I just, for simplicity, kind of just chalked it up. So they're not exactly the same, but they were close enough for me to do this. Would have been a bit more work if we needed to share one across the top and one across the bottom. So then I just have it loop over, the data in X rows and data in Y rows and all of the axes rows. Since it's 2 by 4, you can just, the first iteration through is the rows. And then we iterate over that row of Y to get the column data, as well as the specific axis we're plotting on. Call scatter. Set up the x-axis with 3 bins for the plots, and set the scientific notation, and use tight layout again. And it's not going to work for some reason.
Where did you generate the XR and the Y?
Within the loop. And I don't know what's going on here. So I'm not getting any figures though. All right, well, we'll try turning on the inline, but all right. Shouldn't, but I'm sure I just confused the notebook horribly, but here's when it works right. This is what my data ended up looking like. So you got, the linear, the quadratic, the cubic, and the quartic, and the different limits. So I probably a little bit much with the iterating over the different dimensions of the arrays, but it's a peek behind how it can be done at least.
So one thing, I know that you can do nested subplots.
Well,
Are we going into that?
we're going to get into some more advanced layouts that might get what you're looking for there. And I apologize, we're probably going to blitz through this a little quickly. Hopefully the notebook is enough probably to go back and clear it up, but we're halfway done, less than half of what I planned, so we'll move a little more quickly to finish off this one so we can get to animations.
I saw that we're not doing baseline,
We're going to probably do that more of a demonstration than real hands-on. So here we're going to start looking, you have advanced layout capabilities. So this was basic, if you want the same plot, just a basic grid of them, maybe share an axis. But oftentimes you don't have just one size. You want one bigger and a bunch of smaller ones. And even more abstract than that, but we'll leave that as an exercise for home. So here we'll get some new data. Basically it's 3 sine curves. And so what we have here is this function called subplot to grid. So it's written by another developer, JJ. And so it has a similar, rows and columns mentality that you have with the other ones. But he abandoned the MATLAB one-based indexing. Decided not to propagate that offense any further. And so in addition to the grid, you give it a location. In this case, 0, 0 is the lower left, I believe. And then, but when you also create one, you can say, I want to span 2 columns. And so we have a 2 by 3 grid, but this one's taking up 2 of the columns. Then we have the same 2 by 3 grid, and we have one in the row 0, the very last one, and then we have one taking up the entire row. And so when we do that, and I have just confused it horribly. Okay, hold on.
Works for me.
That's good. Glad to hear it. That's now twice it's done that. You said you didn't need to necessarily run it with the PyLab, right?
So, if you're drawing with one of the GUI backends, you want to make sure that the event loop integration is on.
Right.
So, do magic GUI PT or whatever.
Okay, and if you don't want it, it shouldn't be using it at all. PyLab inline should just be fine.
PyLab inline is fine, but if you make any plots with the GUI event,
Okay.
you're gonna hang.
Right, I was just trying to do inline here and it wasn't.
So, for some of the stuff.
I just changed the draw to show.
All right, well, we're going to handle this way.
Alright, so just change the draw to show. Don't even do PyLab inline when it works.
Okay, so I'll just deal with out-of-line figures. So we come back here, get the data, do the plots. All right. So, like we said, excuse me, upper left, not lower left. So 0, 0 is the upper left. So row 0, upper. We said it was going to span 2 columns. Here are 2 columns. And then there's this one right here is this guy. And then, whoa. So, and then this one says, give me same grid, 2 rows, 3 columns. I want you to start at row 1, column 0, right here, and span 3 columns.
So we could actually
Right here.
do like a smaller grid for the bottom.
You can do a lot of arbitrary layouts with this. It's very flexible, very powerful, and you still get the benefits of tight layout here. So that's subplot to grid. That's another way of doing it. Just keep blitzing through here. The last one is the most complex, but the most featureful, we'll say. And so you have axes divider and image grid, which is part of this axes grid toolkit. This was also written by JJ. And so it basically attempts to give Matplotlib a layout engine for runtime laying out of where the axes are located. And attaching one axis to another and giving it an arbitrary size in terms of percentage of the plot or in terms of point size, pixel, any option you can likely think of is probably there. And so one way of using this is we can just, in the same, make an axis, and I'll make a plot here. And so you have this call to make axes locatable. And that kind of opts in to the, you import that from the axes grid toolkit. And so you opt into that layout engine. And so then you can make another axis and say, divider, I want to append an axis to the right of the other one I had. And I want some padding here. And it's going to take up 33% of the space. And we'll do another one on the right. And so each of those is taking up 33%. And so when we run it, you end up with this guy and these two.
Because those are not 33%.
It's 33% of the space that
Remains.
I believe so. Yes, it is not. It does not give you the 3-to-1. I thought that at 1.2. So there's some playing. I'm not sure I fully grasp exactly how it stacks. But if you look, it's about half and half. But the important part is you can just, tack axes to the right of another one, and it, resizes it, keeps the padding between them. And so that's one way, is just using the append axes. Another way, and this is the more complex one. Do you have a question over there?
Yeah, and all these, for subplots, you can call subplots adjust and get the left, right, and
Yeah, you can
keep that spacing. Does that work on these as well, or is there a separate?
I believe it works on these as far as controlling the margins on the figure. I don't know that it uses that for the spacing in between them. But I believe all these do end up somewhere as a subplot object that will respond to that. So this one's nice and complex, and so I'm going to breeze through this, but you're basically creating a full layout of what you want. So here, horizontally, I have one scaled column of a size 2, a fixed column, another scaled column, and then another tiny fixed column. So that's your horizontal layout. Vertically, we have scaled at 1, a fixed at 0.5, and another scaled at 1. So the fixed stay at that fixed size, no matter how big you make the figure. And then the scaled ones take up the appropriate amount. So you have this one should be a 2 to 3 ratio here of the scaleds. These should be equal.
What are the numbers for add axes?
Add axes, I just created, so in this case, I didn't use the subplots command. I just created a bunch of random axes. This size does not really matter. It's arbitrary, because basically you need to create a bunch of axes so that they can be set, okay, I want the divider to control my size. I mean, this is advanced of the advanced here. And it's not gonna, we're not gonna spend the time that really it would take to truly grok this in one sitting. So I recommend, after I blow through this, you know, if you're interested, take your time and go through it later. What we end up with here is these 3 plots. So I said this first one, 0, 0, and here it takes up the lower left. So this is the one where it's lower left. It breaks its own convention. And so it grabbed this one because I said, okay, I want you to take up 0, 0, which was the scaled here, scaled 2, scaled 1. And then this one, I said 2, 0, so that's over here, starting 0, 1, 2, the scale of 3, a tiny little bit of padding over here. And then this one I actually told, by giving it 2 x's, I told it to take up from 0 to 2. So it takes up actually the first 2 columns on this row, which is why it extends over the padding that's between these 2. If you think you divided the bottom row up into 4 pieces, a little piece over here, this took up the first 2 coming down here. It's really powerful. It can be a little difficult to follow, but when you need the most detailed in terms of laying out your arbitrary plot that makes you happy, you can get there.
Would there be a sprint to unify all the
There could be a sprint to do a lot of things in Matplotlib, and we welcome it, but with the limited development effort, these things kind of, Matplotlib dates back probably a good 10 years, and so the Python language has evolved heavily, so we wouldn't implement things now the way they are. And also, you know, better ways of doing things have been stapled on top of the old way of doing things. And so
is someone enforcing the 0 indexing and 1 indexing for the things? Because I can see how you would not want to break backward compatibility, but in the long term, it's still confusing to have something being 1 index.
the 1 versus 0 to me is annoying, but you get around if you can avoid using add subplots, you're always using 0 based. What kind of struck me here was with the divider here, 0, 0 is lower left.
Yeah.
With the other one, it's 0, 0 is upper left. And that's pretty mentally jarring for 2 things that are current.
Yeah.
So continuing our blitzkrieg through the laying out, there's also an image grid. So this is a way of, you know, the same kind of thing as we just did of having multiple axes, and yet a third way of laying them out. Here we give it a figure, and the 1, 1, 1 is our good old friend from the subplots. And you give it a grid here, and you can control some padding. But basically what image grid does is allows you, when you're doing image plots, p-colors, anything involving a color table, it allows you to share the color table between figures. And so if you've ever dealt with subplots and color bars, you end up taking part of your subplot and using that color bar, and you can end up with 4 or 8 or however many panels you have. You have one for each panel, and oftentimes that color bar is the same across all panels. And so this makes it an easy way to get that, to control how that color bar is shared and distributed across them. So here, for instance, I say I want a color bar at the right. I want each one to have it, though, and I want the labels only on the left side of this grid, since I'm using different color tables. And so it's the same kind of thing like we saw with the subplots, where you get rid of the redundant labels, because I said I want the left and lower labels. You get the ones down here, and on the left side, but we get rid of the junk in the middle. And each one gets a color table real close to it. A little complex, but it can simplify things once you wrap your head around it. On the other hand, if we just change it to, say, color bar single, and use the same color bar across them all, so you end up with one big color bar. It stretches from the top to the bottom of the plot. A little bit of padding, and you end up with a lot more space for your plots. One more thing, and this isn't really an axes layouts, but it is a nice feature that goes back to making it easy to automate your plots, is this anchored artist concept. So a lot of times, for instance, if you want to label your subplots with A, B, C, D, E, F, it's difficult to get that text to show up. You have to figure out where in your data coordinates that text should show up, or try to grok the transforms to figure out how you can put that there. Anchored artist makes it very easy to have any number of artists set to a specific location of an axis. And so there's a lot of examples here. This is taken out an example in the Matplotlib gallery. I'm just going to show you here, except of course it's going to core dump on me. There we go. Okay. So we see here is just different ways of anchoring sized objects. We can anchor to the lower left corner, or the upper left corner, or the upper left above the edge of the figure. Anywhere you want. There's even a fixed scale here, if you need that for reference on some figures. And so if you need easy way to draw certain artists in corners and without having to play with complex transforms, I encourage you to take a look. It's not difficult to get these artists drawn on here. It's once you get familiar with the calls. And it's worth it, again, to make those plots easily just churn out and not have to go into Photoshop or play with Word and their annotations to get your sub-panels labeled. So for that, I'm going to close off here on axes, and we'll go back to hopefully a less brisk pace through animations here. So one of the recent additions to Matplotlib is handling timed events and animations. And for this, you definitely do not want to be running inline at all. You have to have the individual GUI windows. I'm trying to make sure. Okay, so I didn't have. This should just work for me. So one of the first things in adding the animations was just adding timers. And basically what timers do is they abstract away, just like the figure object abstracts away all the details of the different GUI toolkits in terms of creating a window and how to draw. The timers try and provide a common interface across all the different backends for being able to do something at a fixed time interval. And believe me, there are many ways those different toolkits decide to do it, so this simplifies things easier. So this first example, we're just going to try and take the title of an axis and update it every 100 milliseconds. And so what we do is we create a callback here. It's a function that's just going to get called every time that timer fires. So you're going to sleep for 100 milliseconds, and then the timer fires, and then it'll call this function. And all it does is set the title on the axis to date time now, just the current date time is a string. It'll convert it to a string, and then we tell the figure. You call it on the figure canvas. You have to start getting into the details here. The canvas is basically an object within the figure that is more directly related to the GUI toolkit. So that's where you can get a lot more, tell it to redraw itself, tell it to get me a timer, things like that. So if you just look for canvas, you can get these methods. And this one in particular just says redraw. After setting the title, handle the redraw. So here we create a timer. We say, I want the interval to be 100 milliseconds. And when you fire, I want you to call this callback, update time, with this parameter. And then for Qt, there's a bug in the timer implementation, so we need to actually force it to refresh the interval here. That's my bad. And then since working in the notebook, if we're holding a reference to timer, if we close the figure, timer will still exist and keep firing, and it gets angry. So we just say, when you close the figure, stop the timer, and everyone's happier. And then here we call timer.start. So if we run this, so you got a figure window pop up, and it's constantly updating every 100 milliseconds, the little clock. So we can actually change that and say update every second. You see it updates more slowly.
Even though you didn't change the interval parameter.
Yeah, that's because I'm using Qt. And because of that bug, this one's really pretty much meaningless. Really, you should be able to just do this. I want a new timer with that interval, but that it doesn't take. And so that makes it very easy to do timed updates, such as when you want to update a plot every 100 milliseconds. And so going back to some of those things we did with the line objects earlier, we can create our figure and make a plot here. But we hold on to that object, the line.
Did somebody say that plot.show got that to display?
Yes, plot.show apparently can help PLT, or depending on how you import Matplotlib, PyPlot. The conventions typically import that as PLT. And so we also make a callback here that handles updating the line.
I'd like to point out that in the import.
Yeah, I did miss that. Someone else told me that already. So up here, if you put an import numpy as np, that should help take care of some problems. So we have this callback here that's for updating the line. It gets passed in a line object and the x and y data. And so on that line, we call setData, which is a method, unsurprisingly, changes the data for the underlying artist. So you can change how that line is drawn. You can make it completely different, or in this case, we're just going to keep iteratively adding new points to it so it draws itself in sequence. If you're not familiar with event-driven programming, it's a common idiom to have this callback that gets called, and you just need to make sure somehow you track state and get it passed around. So this one takes a lot of arguments, but because integers, you can't actually change their value, we store that as an attribute on the function. You could also make a class, and I think I'll do that in a second, but this is shorter. And so we need to track that current index that's going to keep getting incremented so that we can add more points from the pool of data. So having that callback set up, we make our new timer, interval 100, 100 milliseconds again. We'll add the callback to update line. This time we give it a whole bunch of things we want it to pass to that callback, the line object as well as the data. And then I'm going to make sure that interval takes and then again, we got to make sure that timer gets stopped on figure close. I was having a lot of problems with my kernels just spinning after closing one of these figures. And that's the magic. If I run that, and callback keeps getting fired every 100 milliseconds, it just keeps adding new data to it. So yeah, it works. Like I said, there's a way to do this with a class. If you start with the same initial boilerplate code, we can make an updating line class. The benefits is it stores a lot of state internally, so you don't have to pass as much. The call method actually takes nothing. But we're now up to probably triple the number of lines of code here. So whatever flavor you like, you still end up with the same behavior.
But when you start getting more complicated animations, you want to go with the class approach.
Correct. I mean, the class approach tends to scale better when you do more complex things. When you have to pass more and more state around, those callbacks with 10 parameters start to get a little difficult to follow. So now it's your guys' turn to try and break your IPython notebooks, since I haven't done this very clearly. And so we'll spend a lot of time doing this, I'm sure, but I think it's a useful exercise, and it's a good precursor to getting working for when we see the increasingly better ways to do animations that build on this. And so right now we're just going to do the same kind of thing. We're going to create a callback function that modifies these line objects, create a new timer, and add. You can actually use one update line callback that changes a line, and then just add multiple callbacks to the timer that changes each line. So you see, when we added the callback up here, we added the callback and we said which line it should pass to it and which data. So you can just do multiple ones of those with the same function. So, and most importantly, don't forget this magic incantation, or your kernel will get very unhappy with you. So let's take a few minutes and attempt to get your hands dirty with that. Please ask questions. If you liked what we already did, you'll like more of it. If you didn't, I'm sorry. So here's what my solution to this was. And so here's the figure that comes up, and here's the interactive parts. And so it draws the figure here. And so, and we'll just close this. So the callback, I just had the one callback takes any line with the corresponding data, and then just like before, store the index and set the data slicing up to that index. Update the draw and make sure we update the line. And here I decided to jump 5 points every time. So here
You jump 10 because you call that twice.
Correct. Well, no, no, you're right. Yes. Because I end up I use the same callback for both lines. So because I just take a line and any data, I just add the same callback twice with different parameters. So kept it somewhat simple, happened to work in this case. Doesn't work in every case, and when we get to animations, it actually works better the other way. But for this one, I was lazy. And lazy is a virtue in a programmer. So on top of this, we have these timer classes, which already makes animations much easier. If you actually looked at Matplotlib's animation examples before, you had to have different incarnations of them for each backend, because you'd have to create the timer object in a different manner for GTK than you did for WX, than you did for TK, etc. And so this gives you one unified interface just to give me a timer that works, and do what you need to with it. So on top of that, we have some animation classes. And so these make use of the timer to simplify making animations repeat or not. to be able to delay after you get done iterating, and the animation can pause at the last frame. Make it easy to control that interval. You can also save animations to movie files if you have FFmpeg or Mencoder. We'll touch on this. It's not something we're going to play with extensively here. That's actually been rewritten extensively. To do blitting, which is a programming technique for basically to try and make the animations more efficient. It will only redraw what it needs to, what's been changed, as opposed to redrawing the entire figure, which with all the ticking and text, it actually can be quite a gain in terms of allowing you to run animations at a faster frame rate. And so we have two main user classes for animations. You have an artist animation and a func animation. And so we'll start here with artist animation. And so what artist animation does is you give it a list of artists. So we played with creating lines and circles and whatnot. All those are artists. And so one of the easiest ways to make an image is just give it a list of them, and it'll animate them at a given interval. And so what we have here is the usual figure boilerplate. We make an empty list to store, we're going to do images. Just a set of IM shows here. We'll make 10 of them with random data. And so every time we call IM show, we're just going to append it to the list. But important to note is these square brackets, meaning it's appending a list itself. So we have a list of artists. And that's because you can draw multiple artists in each frame of the animation. And so we create this animation object. We give it that sequence of collections of artists. We give it the figure it's going to work on and how often we want it to update. And did no worky. Helps when you run all of the boxes. There we go.
So this is
just a series of IM shows. And actually, certain artists, it's kind of a pain to change their data. And so this is an easier way to just create multiple ones. P-color is another fine example of where it's difficult to change the data underneath. And so it's easier just give me a bunch of P-colors and I can animate them. And so, like I was saying, we can make one run only once. So we can say repeat, or excuse me, let's come up here, I was skipping. We can do a repeat delay. So for on this one, it's going to cycle through the 10 frames and then it will wait. 1, 2, 3. So it's a nice little feature, not as easy to do with the timer events. Another feature of this is you can have it not repeat. And so it handles that for you. Then it's done. It just sits there. So just 10. So you just need to say repeat equals false. Same. Everything else is just the same. Just say I don't want to repeat, and it won't repeat. And so, like I said, that you have that list of lists, which is a little obtuse if you're just doing a single IM show. It's a little weird. But here, for instance, if we want, we're going to have a green circle that moves in a circle around the center as well as our IM shows. It's a little arbitrary, but you could pretend it's the output of some feature identification algorithm running on top of your image data. And so by just having those circles included in the artist, it's very easy to just have that sequence go. So as long as you have a collection of artists, it's very easy to make this animation. Func animation is good.
Does that have a save thing?
D-save?
Yeah.
Coming up. I don't want to get too sidetracked with it because if some platforms may or not be good for that. And like I said, the release version of Matplotlib is not up to date as far as the good way, I'd say, to do it. It's got a lot more options now in development branch.
Are you going to tell us all about it?
Oh, yeah, we'll cover. I'll let you know when we get there. So func animation, we go back to the callbacks we were just looking at with the timer events. It's a bit more involved in terms of tracking state. but it gives you a lot more flexibility and possibly efficiency. I mean, it's not necessarily efficient to keep creating, especially for a long animation, 100 separate objects, especially if they're all duplicating data. It's a lot easier just to say, okay, display this part of my data, don't display it all. For line objects and other things that are easy to update, this works great. And so, here we'll create some more data. We'll be the decaying sine wave we looked at before. Get the same line, so all this is familiar. And here's our update line callback. So what's different from the timer event example is we have an extra parameter here, frame. So what that is just some piece of frame data. By default, it's going to be a counter that indicates what frame. So you can use as an index to slice the data you're setting on the line. And so with using func animation here, the callback reduces to a single line. And then you just need to pass func animation to figure, just like artist animation. Instead of the artist, you give it the callback, as well as besides the frame, any other information you want it to have. In this case, I pass it the line and the data. And then I want this one, I'm going to try and melt my laptop and go every 50 milliseconds.
Hey Ryan, is there some way to make it grab some initialization frame first?
Just wait, Ben. Just wait. So, the basic function animation here, just same as the event one, just a little bit shorter, a little bit easier maybe. And then we'll start using more of the advanced features that are definitely more difficult with the timers. So if you're so inclined, let's go ahead and redo that last one. It's the same data we had before. Line 1, line 2, two decaying sine curves. And let's just use the simplified callback and func animation so you can get a feel for it. One little part here, in terms of it actually doesn't repeat. I was never actually looking at it here long enough to see that it didn't repeat. So we have to tell it how many frames we're going to draw, because those callbacks can just do arbitrary things to the data and they never actually have to repeat anything. But in this case, we just kind of want a looping animation. So when you say, we have how many frames? So we give it the size of the data. And that should repeat. So if you're looking at your exercises and wondering why they're not repeating, that's because I showed you wrong. There we go. Who have been playing, let's move on. Keep going here. Got about 35 minutes left. So here's my solution to that problem. So get my, let's get 2 lines. So again, both there. Notice this time in the solution, had the frames .t equals t dot size. And so I have one callback that takes everything, get passed in the frame number, and both lines and all the data. At some point, you can start making big classes that handle these things, but I didn't feel like it. And then here, I try to speed it up with a faster refresh, so I don't have to wait so long for it to loop around.
If we wanted to have this in its own module or in its own file, what do we need to have in addition to this? So we would have a pyplot.show at the end.
Pyplot.show. So if you're going to put this in its own module, Matplotlib pyplot.show should only be called once. So that needs to, if you think of your script more as an executable, that should kind of be the end of your executable. It's basically equivalent to a call of exec or main loop or something like that. But your object, your animation object, doesn't need to can be sitting there as a separate object in a module somewhere, and doing all the Matplotlib low-level code, and then you can just import your own animation class and start it. Or better yet, when if you make it a subclass of some of our other animation objects, it'll actually get attached to the figure and it will start when the figure gets raised. If you notice, we don't actually ever say start. It just knows when the figure appears to start the animation.
Do we need a code to redraw somewhere also? Or?
That's one of the things that the animation takes care of it for you, is it knows it basically just says, you do what you need to do to update the frame, and it should handle everything else that is common to all the animations. So some of the advanced tricks. You notice we passed in here that frames as a number, just how many frames. And then it gets passed directly to the callback. Those things are arbitrary. As long as the callback handles it, and as long as it's some kind of sequence or can produce, in this case it takes a number and it makes a sequence from it. It calls range using that integer. And so it ranges from 0 to whatever number you give it. But it can be an arbitrary sequence or a generator. And then so long as whatever is generated, your callback handles, it can use it. So, you know, it can be an iterator, generator, sequence of anything. And so what we can do here is you don't have to have a repeating animation. You can do a procedural, just have some repeated call that puts new points on the screen. And so what I have here is an example doing the Sierpinski triangle. If you're not familiar with it, it's kind of a fractal type of pattern that keeps generating. You add points and you end up with this pretty pattern. And so what we have here is we have a generator. We set up some initial state. And then we just go in, looping forever, and we just keep yielding the correct calculation for the Sierpinski triangle. As far as animation is concerned, all you need to know is this function enters and just keeps, every time you call next on it, it yields a new random number according to some set pattern. We have a callback here for update line, which should look familiar. This time, instead of just calling it frames, we call it new data. And we get an L, which is the line, and X and Y data. And so in this case, new data, based on what this is doing, it's actually a pair, an XY. And so it takes that apart and appends them, because these two are lists, and then sets them on the line. It uses lists because it's difficult to append to a NumPy array. You end up with doing a lot of resizes. The flip side is you end up copying here, but either way, if you keep wanting to add points, lists are probably an easier one to handle. Here we're returning the line array. We'll get to that. It's used for blitting. Basically it's returning the artist that has changed, and we'll cover that more in a second. Here's the standard figure boilerplate. We create a line object by hand. We could have done the same, empty plot command that I've been using and just changed it up. Added the line of to the axes and set the limits. It's another function used for blitting here. So same basic call though. We have the figure, the callback. This time frames is being given this generator. We have the same, the arguments that get passed to the callback. Our frame rate, which I'm going 10 milliseconds. We'll see if the computer keeps up. I told it to blit because I'm trying to get it to run quickly, and for this one, it helps. I'm pretty sure, yeah, we'll cover blitting in full in a second.
If you were to do the interval to be 10 milliseconds and your computer can't keep up, when you save it to a file, that will it be right?
Yes, if you're saving to a file, it will write out every image in the sequence, and then when it tells FFmpeg or mencoder, it says, this is the frame rate you should use. It's not doing any kind of capture. So here, if we run it, you can see just every 10 milliseconds it's adding new and more points, and you can start to see the triangle pattern of the Sierpinski triangle appear. No looping, the data is not pre-computed. It's doing that every time it asks for new data for the frame. And it has a lot of applications you can think of in terms of, trying to get new data from a file, reading from a serial port. You name it, it does have the ability, and you don't have to keep around the old data. I mean, obviously, if you ran something like this for a long enough time, you're going to have too many points to keep up. But, if you start aging out old points, you could have an online data record or data viewing program out of this with not too many lines of code. So one of the other advanced things is saving to a file. And basically we have a couple, I hate reusing the word backends, but that's what they amount to. It's just different abstractions on top of two popular open source movie creation programs. I looked long and hard for a Python library that works with video, and as far as I can tell, nothing exists. So the best you can do is calling out to the command line and using these utilities. In the 1.1 version, it basically creates a bunch of temporary files and then stitches them together in a movie file without a lot of control as far as quality. You control frame rate and sometimes codec. They respond differently, and it's very difficult to tell what codec is actually valid. So MPEG-4 works pretty well in that version. So, but here I'll show just how easy it is to save an image or save a movie file. And so here, here my kernel's busy. I told it to start this one, and so it's creating a figure and adding the axes as always. This is the artist animation one we did a few minutes ago, and now it just ran it. You see, I also told it, go ahead and save images.mp4, and I want 15 frames per second. So I did 50 frames, 15 frames per second, and yeah, so should be about 3 seconds, I believe. So I'll come over here. So there's the MP4 file. If I run that, very psychedelic, but you get the idea. So I'm not emphasizing it much here, but that is an important feature of it, is being able to easily write out a movie file. One of the reasons I'm not emphasizing as much is because the development version of Matplotlib has a better implementation in terms of being able to control codecs, pass arbitrary, if you know enough about mencoder or FFmpeg, you can really tune what parameters are being passed. And you have a lot more control over the quality of the movie file. And it also, we don't have to use the temporary files anymore. You can use, I don't know how well it works on Windows, sorry, but at least on Unix you have Unix-style pipes, and so you can pipe the data directly to FFmpeg, and it is probably a 5 to 10-fold increase in how quickly you can write movie files. Okay, so it is possible it works on Windows. But either way, even if the pipe doesn't work, they'd still have the temporary file writers, and you can still take advantage of the increased flexibility in terms of quality and codecs. The landscape of terms of how things are compressed and then how the frames are contained is a gnarly, gnarly world. And I think probably your bigger hurdle would be getting FFmpeg or mencoder installed on Windows than getting Matplotlib to work with it. The other advanced feature here, go ahead.
For that one, is there any quality control at all?
No.
It looks like there were a few artifacts.
There was part of that is IAMShow was doing the interpolation. I think there were some artifacts. I think it might have been a hard-coded bit rate that gave me decent quality. I know if I ran with default quality on FFmpeg, on the text there were lots of artifacts of the compression.
Yeah.
And so I tried to crank it up by default, but now on Matplotlib Gitmaster, it's a lot easier to tune that as you want. So if you know the incantation on FFmpeg that you don't have to specify bit rate, but you can specify other compression techniques, then you can get what you want out.
Okay. Do you mind trying with interpolation equals nearest?
Sure. So we try interpolation. So we'll turn off the blurriness of the data. We should just get a 20 by 20 blocky grid here. So amazing the difference that makes. So that's there. Come over here. I don't know where that came from. There, if you can see some compression artifacts there for sure. So that was definitely one of the big things. I was not thrilled with the first commit of the writing stuff, but at some point it just had to go in. So luckily I had some time to update the writing support. So you notice here for this, I did turn on the blitting, and that's partially because 10 milliseconds, if I don't do blitting, it starts slowing down. This probably isn't a fantastic example of it yet. But 10 milliseconds is difficult to keep up with when you have to keep redrawing everything in this box. All the text labels every time through, every 10 milliseconds. You're basically spending more time than 10 milliseconds drawing and you end up backing up.
Blitting is just incremental drawing?
What blitting amounts to is you can save a rectangle, and then you can paste that rectangle in there to erase the frame, and only draw what's been changed. So in this instance, you can save a rectangle that has your tick labels, and anything else that's static in the image, paste it in and have a clean slate, and then just draw the couple lines that need refreshing. And so it's not on by default because you have to really opt in and make sure you figure out what's going on. You have to give it this initialization function that tells it, okay, this is how to draw a clean slate. So it knows I can call this function, draw it, and then I can grab the rectangle, and that's clean. And then you have to return what artist changed to get the clean slate. And then when you do the callback, since callbacks can do anything, it could call out to a serial port and decide to do nothing. It can update 25 artists. You return the things that have changed, so it knows I need to draw line 1 and line 2 need to be called to drawn after I've cleaned the slate. And so it's a bit more work, but if you're trying to eke out performance in interactive animations, or if you're sitting here running the GUI window and it's not running fast enough for you on your laptop, it can eke out some performance. There's also been occasionally certain backends don't like it. You Mac users, which seem to be most of you, I know the Mac OS backend, last I checked in, did not like blitting. So for the majority of you, I'm sorry, that probably doesn't apply right now. But I'm sure we would, if anyone wants to try and figure out what's wrong with blitting, we would love a patch. So anyhow, to actually see how blitting works here, here's the same, fake data, create the figure, make our 2 lines. And so it's very much the same here as far as, calling update data. We just need to return the 2 lines. And then we need to give it that initial clean slate here, which sets the lines to have no data, so they don't draw anything. Technically, if you want clean slate to start with partial lines, you could have that here. You could have half a line drawn and return them. And then, we call func. It defaults, if you don't do that, it defaults to use the first thing coming off of frames. So often that's index 0, and often that might get you the right result. It can cause problems. It can work. I'm not sold on the entire blitting interface right now, but this was easy enough to make a module that came on top of Matplotlib without interfering with things too much. I think if we deeply integrated in terms of tracking what artists need to be animated, you could probably do a little better. But for a first cut, this worked fairly well.
So on the init, the clean slate, how does it know what the extents of the x and the y axis? I haven't given it any data.
It looks at the axes that are associated with the artists and grabs those. So for line 1, it knows what axes it's attached to, and it uses the bounding box for that, which includes its tick labels.
Oh, because you already computed it on, I see. You already computed once, line 1 and line 2.
Yeah, exactly. Mm-hmm. But also, think of clean slate more in terms of graphics area. And so while your plot limits might change, in terms of the bounding box of that plotting area, pixel-wise, that's not really moving unless you blow up the figure. And then it knows to, when you resize the figure, it knows to get new clean slates. That's a lot of what, probably a good 3/4 of the code involved in here is involved in trying to make blitting work. And it works in some cases, but not enough that I love turning it on by default. So other than telling it blit and giving it a good init function, and it tries its best if you don't give it one, it works. So notice how fast this one manages to update right now. It really just keeps going, not the painfully slow wait it was. So if we turn off blitting, it is noticeably slower. Oh yeah, because you got more and more points, and so you're drawing every one of those, drawing everything else. If you look at this, I've got it set to 10 milliseconds with 500 points. So that should be 5 seconds. It's taken longer than 5 seconds without blitting. But if you turn on blitting, 1, 2, 3, 4, 5, and I think I counted fast. So you managed to almost make your performance. I mean, in that case, you're making a difference. So now we're just going to get to, I'll call it gratuitous eye candy. John Hunter wrote this example that basically runs a differential equation solver for a double pendulum system. And that's well outside the scope of my knowledge. So I'm just going to take it that it works. But here's the kind of thing that, it's probably more a sexy application of the animations than just arbitrary sine waves. And actually, I think there's some potential with this particular example. You could probably, if the solver runs fast enough in a single time step, you could probably run that directly in the callback instead of running it all up front, if you so desired. But I think that's definitely was a more compelling example to me of what you can do with the animations. And once you get outside here, I mean, all this up here is setting up the numerical solver and what you need to solve the differential equations. It's only down here that you get, again, to the simple, okay, here's setting up the time because it updates the timestamp of the simulation, the init for the blit, the callback, and call the animation. So, I mean, again, the animation, the plotting code here, including the animation, is 15, 20 lines.
Sorry, what is the...
What are you looking for?
If you see this anime, it calls on X1, is that just a global?
Yeah, he definitely made use of the globals here. Different style than I've been doing. It's up to you if you like globals or not. I personally don't, but I'm not here to proselytize about that. Exercise and given time, I'm going to skip this one, but this one is a bigger, more complex animation. So if you're really interested, you can do subplots animated. And animate a whole bunch of lines at once, and actually each one of these is 3 lines. But blitting works across multiple subplots, and the animations work, and if you save it out, you'll get all the entire figure in one movie file. So I just want to, I don't have time to run through exercises, but I do want to touch on basemap. For those of you, how many have heard of basemap before? How many have actually used basemap? Okay. And we'll fill this out. How many of you work with spatial data, maps and transforms? Okay, so I think this might be new to some of you who might be able to make use of it. So basemap is a toolkit for Matplotlib that extends it to make it easy to work with spatial data in terms of geographic projections and including a lot of default maps, coastlines, topography, or the blue marble image for the Earth. And warp images, there's great circle calculations. So I'll run through some of these. There was some exercises, but we're kind of running out of time, so I just want to get you guys exposed and see, if you weren't using basemap for doing spatial work, you're missing out. It really simplifies some things. So for instance, oh, I did it wrong again. There we go. Okay, so for instance here, we can set up a projection here, and we're going to center on the southern plains of the United States for some reason. For instance, if we want to plot a dot in Austin. So we'll take that, and basically basemap works around it. First you create this geographic projection, and if you have one that you love, odds are it's in there. The list of them includes many I haven't heard of, but admittedly I don't know them all. This one, in this case, it is Lamber's azimuthal equal area. The names can be a little cryptic. The doc string's pretty good though. So for instance, we can take the lat lon of Austin, project it into projected coordinates, and then plot it.
Is that a rectangle in the sphere that we drew, the minus 110 to 25? Is that what
This defines the rectangle, yeah. So there's a green dot in Austin. And you can see after projecting it, we went from those lat lons to these weird numbers that are basically meters from the upper left or lower right, or upper left or lower left. I never keep it straight, but the important part is it handles that. You can give it lat lons, and as long as you use that to project them, it will convert them to things that plot on the map.
Can I briefly ask what's lat 0, lon 0?
Some projections have certain lat 0, lon 0. It depends on the projection. Some have lat 0, lat 1. The different projections have different parameters that define them. Some have a lat of true scale, where a circle is actually a circle.
Like the center of the closest point?
Some of those are, yeah. Some of those are the closest.
It's all documented.
Yeah.
Okay.
And it's based on if you're familiar with projections, the Proj4 library is the back end for all this. And so anything it can do, base map wraps.
No, I've actually never worked with maps at all.
Okay.
So I'm kind of trying to learn what that is.
You got to keep having this display. So we have a bunch of maps, coastlines, countries, states of the United States, and the NASA blue marble image, which makes a gorgeous background. Obviously, some data you don't want to do that, but it's available, and it's warping that image appropriate to the projection. So if you had some skewed projection, or you look up at the North Pole, depending on what you're doing, it warps it properly for you. This particular one, we're using the Lambert's azimuthal equal area, but we could do Lambert's conformal conic, Mala-wide. You can even do orthographic, or there's a geostationary projection too. So for doing satellite data. Projections are just complex mappings from your on a sphere you have 3 parameters, and on a map you have 2, so you have a variety of ways to project from 3 to 2 coordinates. And there's no one that's conducively better than the other. It depends on what you're trading off. All of them end up distorting areas of things in one way or another. So here we can just make a little grid and contour it on there. Some arbitrary data, but there's a contour analysis on a map. For me as a meteorologist, that's the map thing is a killer feature of Matplotlib, and makes doing weather maps and analysis allows me to continue doing that in Python instead of using our traditional tools, which are old and crufty. So
Is there an aspect ratio going on there?
there is some aspect ratio. Basemap tries to manage that to some extent, so that when you zoom in, it tries to keep things so you don't distort it any further than the projection's already done. This was, the projection's going to distort things, yes. There's no way around that.
So you basically don't use GIS tools anymore?
I was never a huge GIS user, but in terms of being able to work, this will display arbitrary shapefiles. I'll cover that in a second, as getting the end here. So I can work with some shapefiles. At least if I have shapefile data and I want to put that on a map, this will work just fine. If I want to include analysis, of some shapefiles, you can do some of that in here. And it's not going to replace ArcGIS by any stretch of the imagination. Right, and you get to stick with Python. And certainly if you have, if you're using GIS tools to take some Python analysis and put it on a map, this serves that, in my opinion, better. And I'll get to some other things here that I think to some spatial users it's killer features. And here was a random walk model walking across the United States. You can fill in the water how you want, fill in the map. This one was drawing the nighttime terminus, or basically, showing where it's night and day on the map. So, and, does the proper things. You can see, midnight sun on this time of the year is up here. If I wanted to change, I won't bother trying to figure out what the right incantation is, but you could change the time of year and see, in the winter where it's always sun, winter northern hemisphere. You can do great circles, so we can, if I put my, so for this is a Mercator projection, and you see the great circle from New York to London. So a straight line flying on the sphere, this is the path it looks like. If you've ever looked at the airplane magazines and wondered why all those lines look like they do, here you go. But if we change the projection from this one to some other projection I've not heard of before, Nomic or something. More importantly, great circles are actually straight lines, but you can see everything else is distorted.
That's super cool. Sorry, they can't be straight lines over.
No, it can't be a straight line over an arbitrary area, but I think the projection's set up such that this one's a straight line.
If you look at the side of a circle, it's...
Okay, that makes sense. So if you look at, it's a cross section through, looking at a circle. And then with custom shapefiles, here we'll plot, we had the draw states command, but you can also just take the shapefile for the United States borders and read it in, and it'll plot it. So there's no calls here to draw states, so it's actually plotting the shapefile I gave it. Oh, I know what the problem is. I didn't copy the data over. A shapefile is a prevalent file format for geospatial data. And so it has support for bringing those in. I don't know why it's come up a little weird right now. It's not quite aligned. I'm not sure what's going on. This is an example ripped out of the map, out of the base map examples, but you can see we took the shape files and we have a list of population densities for the individual states, and so we can loop over that shape file and color the individual states based on their population density. And so it gets a little more of a ArcGIS type of application, but depends on how sophisticated you're using other tools to whether or not this meets your needs. And there are a variety of other examples. I can go on hurricane tracks and plots, the TSOT plots, if I'm pronouncing that right, showing the amount of distortion for a given projection across the domain. So you basically take a circle and keep drawing it in different locations. You can see how the circle of equal area changes shape to see what the projection's actually doing. And so there's a lot. Jeff Whitaker, who works for the National Oceanic Atmospheric Administration, has put a lot of work into making this a very nice package, in addition to Matplotlib for your GIS data needs. So with that, there's 5 minutes left.
Bit of a side note, the update cycle for base map is disjointed from Matplotlib, so base map could get an update, maybe release a new update at a totally different time than Matplotlib. So Matplotlib has been, about a year since we've done a full release. Meanwhile, Jeff Whitaker's done 2 in the past year, I think. So
for those of you who can't hear Ben, it's the release cycles for base map and Matplotlib are independent. Base map is, as much as a toolkit for Matplotlib can be independent, it's independent. Jeff develops it independently and will release, when he sees things. So you can get updates differently from Matplotlib. So just because you haven't seen an update from Matplotlib, you can keep looking for base map updates. Jeff regularly adds features. Until I started this tutorial, I didn't realize things like the night terminus, and I think great circles were new to me. And so a lot of other features there. If you go digging into it, there's a lot to be had.
Did anyone have problems installing basement? When I hit install, I was having some problems with it. Is it?
Yeah, that.
It's more of a geo. And the geos library, sometimes you have to get that installed correctly before you install base map. Base map depends on all that first.
Was this falling in geos?
geos.
NetCDF time, I don't believe. I think base map.
Still includes that? I know. Oh, it's required?
Yeah, it's required. It doesn't, if you do a Python setup.py info, it doesn't pull that in for you because it's a non-Python module.
Is that part of NetCDF?
You have to install the geos library separately.
For NetCDF time?
It depends on what packages, but yeah.
Okay.
But it's not available in the Python package.
I've been fortunate not to have a lot of problems installing, but I know GEOS. I mean, it relies on some very complex C++ geospatial libraries, and so sometimes you can hit, C++ compile incompatibilities and things blow up. Jeff's usually pretty good about reading mailing lists. My best advice is if you can find pre-built packages for your platform, that's the best thing to do. That's, let's see, have time really? Oh, for the day-night. Oh, daytime. Okay, so in, okay. Usually usually for the most part it includes what it can as its own, so it sounds like a packaging bug. Which one? Yes, yes.
Is it safe to assume that any keyword argument should Matplotlib plot will be taken by that?
Yes. So the plotting methods are on the base map object, but it pretty much just is, it does whatever it needs to keep internal state consistent in terms of the aspect ratio, and then forwards everything on to the Matplotlib calls. So it's just wrapping everything.
If I look at the help of Matplotlib.
Yes, Matplotlib's help for, yes. All the help from Matplotlib applies in terms of plotting methods to base map. And in fact, it doesn't do anything in terms of converting your data automatically. You still have to manually call the base map instance to do the projection of your data points.
And in the development version, there is a new function being added to deal with if your map projection, let's say some map projection like being between negative 180 and 180, and other map projections like being between 0 and 360. There's a function being added in the latest version that will help you shift around your data, so that way, like if you're plotting something that goes across the international date line or something, it doesn't get you a line that draws across the map and then back to the spot. There's a new function being added in the development version right now.
So one of the features upcoming is basically dealing with wrapping problems. When you deal with going across 0 to 360 or negative 180 plus 180, you can have it automatically, or call a function to wrap your data for you so you don't have to deal with those problems.
Called shift data or shift grid or something.
I know there's also a function for, it'll mask oceans for you. So if you only want to plot your data over land and not over the ocean, you can have it mask out those areas.
So does this mean that I can use base map in the animation stuff that we talked about? Can I make like movies or cross
Yeah, it should be possible, yes. I'm trying to remember, the only reason I'm saying should
be is because I'm trying to remember if there's an example. I'm not finding it now, but I mean, it's still based on axes, objects, and everything else, so there's no reason you can't use them together. My only advice would be make sure base map instances are expensive, and plotting the maps can be expensive, so you definitely probably want to run with blitting and make sure you don't recreate base map instances.
Yeah.
I mean, because there's a lot of math involved in those projections.
Certainly do good.
So here's an example, again, things I didn't know existed, of doing cosmic ray sources for a sky map. So for the astronomy community, you don't have to be inward focused here. You can look out.
Wow.
So all credit for that goes to either Jeff or if someone submitted that patch. I don't know who, but I know that's a recent ad.
I was going to ask about astronomy stuff, so.
There you go.
Does it only, it's just a plotting tool, or does it have like computation stuff? Distance between two cities and...
I think you could use the projections to figure out distance, at least on the projected map, and you have an orthographic projection, which is basically no projection, or look as if you were looking down at a sphere kind of projection. I think you can do calculations with the Great Circle feature.
These use PyProj underneath, or these use PyProj, and there's a wrapper for that called PyProj.
I think it.
That kind of way. Because of this projection stuff, you can just use that.
Mm-hmm.
It's a little lighter.
And there are all sorts of other examples here in terms of working with images and warping them and using GDAL, which is another open source geospatial. It stands for Geospatial Data Analysis Library, and so you can work with that with basemap to analyze using GDAL, which has Python wrappers, and then plot using basemap. And so, there's a
separate library in terms of the computation stuff.
By and large, Jeff includes things that are widely used. So it depends on what your application is. Anybody else?
Examples for more astronomy work.
I'm staring at 2 in the examples directory.
I guess the space telescope guys would probably be.
Yeah, Perry Greenfield and Michael go through them. And I would be honest, I would go look at whoever contributed that feature in the mailing list and see, if it was. I doubt it. I'm 99.999% sure it wasn't Jeff himself. Being another meteorologist and looking up, not so much. Any other questions? All right, well, I've kept you 4 minutes long, so hope you enjoyed it. Feel free to find me afterwards if you got other questions, comments, hated it, liked it. Appreciate your attention. Thanks.
Many different Python installs.
Have they got it? Did they get it or not?
I'll make sure to get one. Yeah, I know. So.
All right, for those of you who came in late, there's a URL up there that. So for those of you, Matplotlib, either the original or version 2. For those of you unfamiliar with the term OO, it stands for object-oriented. And so what we're going to cover here is attempting to do Matplotlib plotting and creating figures without using the traditional PyPlot interface. It helps to understand what's going on under the hood. You will really see how much the PyPlot interface just handles for you, and then we'll also cover doing some things like, instead of using plotting methods, trying to create artists by hand, and seeing what goes on under the hood when you call these simple plot methods. So we have here to start is just the usual, bare basic kind of beginning of a script in Matplotlib. You have your imported NumPy and Matplotlib's PyPlot, and we'll make some random data. And then here we make a scatter plot. set the limits, give it a title, and call show, which you really don't need in the notebook. And you get a nice, pretty graph, has a title, you see random data. Shift-Enter. So Shift-Enter will run the current cell and move to the next one. Control-Enter will run the current cell without moving.
You got to appear in line.
Yes. Think.
Yeah.
Kernel busy.
I'm getting external, like it's just not running it. All right.
If it didn't work right away to appear.
It's putting it off the screen, off the notebook, so you have to.
Just to be clear, before you start the.
Oh yeah, mine's printed out off the screen as well.
For users who didn't start with -pilot, you need to do %pilot.
Yeah.
Okay, so what Min just said was, if you haven't, if you didn't start with -pylab, which I didn't think I had, but I must have, if you just do %pylab space inline, at any box, just make a new one, or does it matter?
Yeah, you can do it again.
Okay, so I could go right here and go %pylab inline, and there you go. I had a lot of issues going back and forth between them with the GUI toolkit, so I just tried to avoid it as much as possible. So that's the usual Matplotlib for any of us, all of us familiar with it. That looks normal. So when using the PyPlot or PyLab interface, it handles a lot of magic under the hood that goes on in terms of creating a figure. Matplotlib supports a wide variety of graphical toolkit backends, as well as the AG image backend.
Restart. Run it so many times last week. Did it restart? Yeah, you just got to restart. Just rerun the block. Right into the block.
2 or 3 different installs.
Oh, okay. Well, I remember what I've been doing now. So for in the notebook, display parentheses.
Sorry.
Display in the yeah. So because we're running an active notebook, to tell them to force it, display the figure in line.
Right.
Aha.
Yeah. This should be the only that's actually working.
Right.
What's a canvas?
Okay. The canvas is the actual GUI widget that's being used.
So there's inside of the
window. Inside the window is the canvas that actually tracks all.
Yeah. And inside the canvas is the figure.
Now the figure contains a canvas, which is just the easiest way to go and get to the reference to the figures.
The figure. Sorry, the figure contains the canvas.
Yeah. It's just going up. It's just basically going higher.
But is it a one-to-one thing?
Yes. Each canvas is one figure. Each figure has one canvas. So definitely an implementation, not implementation, is able to load up detail.
Yeah.
This is why that's so bad. How would you use your C file for you? A setting like cells. So that would be QT back in, and then for you can instead of QT for rag, we match OSX. So we have a Mac backend.
I actually do have a Matplotlib one in here.
Yeah, because we need to put this show.
Oh, yeah, you are going to reload everything.
Yeah, it's Firefox too.
I was something about.
So we have it, no GUI toolkit with AG, and then also Qt4, WX Windows, GTK, Cocoa on Mac OS, FLTK, and TK. So all of those different toolkits, so you have maximum odds of something working on any given platform. But as a consequence, there's a lot of magic in order to abstract that away so you can just call figure and get the appropriate window. It also, PyLab provides more of a stateful interface. So it's tracking what is the current figure, what is the current axes, so that you need to make sure when you're using that interface, you keep track, okay, I'm done with this figure, now I can move on to the next one. And so if you don't hold on to the appropriate objects, it's very difficult to go back and modify them. So it's pretty much like global variables. And programming maybe 201 is global variables are bad. And so it makes a very MATLAB-like interface in terms of ease of creating figures, but from a code maintainability and in terms of using the full power of the interface, you're not getting quite everything out of it. So if we move to the next one, you see here, and this is where I'm going to get in trouble with the inline. So if I go here and get rid of show, yeah, so for those of you doing the inline and not getting windows up, get rid of the Qt4 and show. Just look like that, and it should. What just happened? There we go. Ha. Okay, so instead of show, we use display fig to tell the IPython notebook to display the figure, but that's specific to the notebook and not Matplotlib. What we see here is first we have to do the, we pick a backend. And so you have this import line from Matplotlib backends. In this case, I chose AG since I'm using inline. AG is the image-only backend. And so will play nicely with the inline setting of the notebook. And so we import this new figure manager, which every backend has a function that is basically used to manage and create new figures. So we call it, and we call new figure manager, say, okay, I want to create figure 1, and then I want to grab, you can use this .canvas.figure to actually grab the figure instance, which is the object you're used to getting when you call pyplot.figure. And obviously that's already a little bit ugly because you're picking one backend. Your script won't work. Well, it'll always work and create an image. You can't, but with this script you can't then you get a GUI window up. If you pick Qt4, it won't work on platforms where you don't have Qt4 installed, et cetera, et cetera. So while it works in terms of getting the right object, it's not very friendly. From there, after we get a figure object, we can use that figure object to create an axes object with this add subplot command. There are other ways to do it. That's pretty much the easiest and most straightforward, which basically just says we're going to create a grid of subplots with one row, one column. I want the first one. We inherited this one-based indexing from Matplotlib or from MATLAB. And then instead of just calling pyplot.scatter and xlim and whatnot, we call these as methods on the axes object. And so you can see if we had more than one figure here, if we wanted a second axes, if we wanted to instead say, let's do 2 rows, and we can do a second one here. Good enough. So now, with that second plot, then there's different limits, but the important part is it's very easy to see which axes you're working on. There's no calls to get current axis. There's no worrying about what is the current axis. It's all very explicit in your code, what object is being used for plotting.
I'm getting an input error on display, or name error, I'm sorry. Where do you...
Display should come from IPython, or from the notebook. Basically, it's a way to tell the notebook to display the figure in line. For most, when you're used to working with normal scripts, that's the equivalent of show. But for the notebook here, we had to change it a little bit. So, like I said, the benefits, it's more object-oriented. You track specific objects just like you would in normal code. I mean, one of the things about when you're using the PyPlot interface, if you're not tracking it, it seems very antithetical to the normal way you program, where you create an object, you create new objects from that, et cetera. So there is a way to do that in Matplotlib. It's just not as well advertised or demonstrated. However, like I said, the trade-offs are you're doing specific to a given backend. And so often the best approach is a mix. So what I tend to do, and
can I quickly?
Absolutely.
You have the ax title. Is the figure, does it have like a collection of axes? Is that what?
That's a good question. Okay, so let me step back for a second and go over the hierarchy here. So what you have is you have a figure which represents one plot window. So if you're working interactively and you bring up a GUI toolkit window, that is a single figure. Each figure has one or more axes objects in there that are actually in control of handling your plot boundaries, the ticking, the actual plot methods are on there, managing the different artists that are being drawn. All of those things are on an axis, and so you can have multiple axes within a single figure. But one figure corresponds to one GUI window or one image.
Does the figure know about the axes that are within?
Yes. Yes, the figure tracks it. And there's actually a lot of, the axis knows what figure it belongs to, and the figure knows what axes it has, et cetera.
And so now I'm doing set title, and so I noticed I put a set title on the other one, each has its own. Is there a figure title on top of these, or what?
There is. The question was about whether or not there's a figure title as well as the axes titles, and there is we call a soup title. Yeah, I don't know if it stands for soup or what, but it's fig dot, or is it? It's P. I know there's PLT in pyplot dot soup title, which will create a title about where it thinks it should go up at the top of the plot. I guess you can give it a location, and so that's a way to basically make a text object that lives outside the axes objects. So often, the best way to address, using the object-oriented type of interface while also not making code that only runs in specific instances is to kind of do a hybrid approach. And so here, we call you go to the PLT as pyplot. So, just have it here explicitly. So we use figure off of pyplot because that handles figuring out what backend should be set, looking at your RC parameters or what was passed in the command line, and sets up all the function objects so everything points correctly. And so all you have to do is use pyplot.figure, and that just works. And anywhere you want to run it that has a proper Matplotlib installed, the script will just work. But from there, we can use the figure object then to make a new axis, just like we did before, and call scatter and all the other appropriate plotting functions directly on the axes. And so you still get the benefit of explicitly managing your objects and tracking what's going on, but you don't have to necessarily figure out what backends are installed, what's available, what makes sense. And then basically you have it bookended by two calls. The figure, one or more figures, and at the very end, a show. And so, same plot, just what I think is probably the best approach as far as code goes.
So if I'm doing, just trying to programmatically generate my figures, instead of show, could I just do like, say fig or?
I believe it's fig dot. So the question was as far as programmatically generating figures instead of show. And so the answer to that is there's a fig.savefig. I think there's also a print figure, and that's the easiest way. Just give it a file name, you give it DPI, and a few other options. And in my experience, that's one of the things Matplotlib does off the bat better than MATLAB. It's just easily programmatically generating figures.
And it should always be done before you call show.
Correct. Yes, that's a good point, is that show should be basically the last thing you do in any script. Last time I checked, I know there's been some discussions, but last time I checked, show can only be called once. And so you should do everything before that, call savefig before then call show. Yeah. There has been some work to try and make it function better when calling show more than once, but certainly in older versions, that's a surefire way to end up with a backtrace.
So what's show actually doing?
Show basically starts the GUI toolkit's event loop. And so if you've ever done any graphical user interface work, you have this loop that just keeps spinning and it gets events and it handles them. And so what you have here in Matplotlib is you set up a whole bunch of data and objects and then you call show and that starts the GUI so events can be handled, your mouse clicks, your keyboard events, anything else that's running. All right, so we'll hit here for a small exercise. It's not particularly in-depth, but we'll go through and go ahead and work to not use the pyplot interface. So there should be no importing matplotlib.pyplot. It should be a lookup in the previous code to try and see about where to go. But what we want to do is make a new figure using new figure manager. Pick your backend of your choice. If you're doing inline, you're probably going to do backend_ag. Use that figure to make an axes object, and then use the axes. They have methods for all plotting commands. In this case, I said step, really, take your pick. I just figured something different other than just a standard line plot. So you already have the data there, and I'll wander around if anyone has questions. If I've been unintentionally vague here, please let me know.
Yeah, okay, so if you change that, you're up max, so change the QC4 act to Mac OS. Try X. Okay, that's different. Here's another plus.
Oh, you mean, yes, yeah, I was in that. Yeah, that's not what I did.
Turn it on.